Morning, good afternoon, everybody. Let's just give it a couple more minutes. Make sure folks are switching from the previous call to this call. So we'll be with you in a couple of minutes. All right, why don't we get started? Okay, good morning, good afternoon, everybody. I'm really excited to kick off this webinar with our partner, SNP Technologies. I'm just gonna do a quick welcome, and then we'll jump right into the content. A little bit of background, myself, I'm Francesco Rieti, I'm the Partner Development Manager from Microsoft. I've been working with SNP Technologies since the beginning of Azure. So I think we're coming up on 10 years probably. Fantastic system integrator partner. You can see the accolades up on screen. They have expertise across the entire platform of Azure, whether it's infrastructure, security, all the way up into application development, data, estate modernization, advanced analytics, Gen AI, and then, of course, all their managed services, very sophisticated managed services, also as a CSP service provider. So not only can they help you with the migrations and the adoption of these Azure technologies, but they can also manage the entire system for you if that's what you require. Today, I'm really excited to present a cast of 3 really smart people, and we're going to do a deep dive on AVS, Azure VMware Services. Many customers out there are looking for ways on what can they do with their on-prem VMware environment. What does the roadmap look like? Do we stay on-prem? Do we go to the cloud? What does that look like? And this presentation, these experts will walk you through and hopefully show you how this is the best, most least intrusive solution or option you have to maintain your VMware environment, but switch to the cloud and start saving some costs with infrastructure management and so forth. So without further ado, I am going to introduce Hussam from Microsoft, and then the rest of the team he'll introduce the rest of the team from SNP. So thank you very much.
Of course, a great introduction, Francesco, and thank you so much for your time here. Hi, everyone. This is Hussam Hilal. I'm a partner solution architect at Microsoft GPS org, and I'm glad here to present my friends from SNP, who's going to be the subject matter experts actually in this call that's going to give us a deep dive on AVS and best practices. So we have Ravi, he's the head for infra and apps at SNP, and also we have Ferouz, he's a practice manager and cybersecurity at SNP Technologies as well. So this is the agenda for today's webinar. We're going to start with an AVS overview and talk about migration, and then we're going to talk more about migration architecture and supported scenarios, cover networking architecture, one of the most kind of interesting topics when you talk about AVS migration. And then we're going to dive into disaster recovery use cases with Site Recovery Manager, and then networking consideration when we work with disaster recovery solutions in general. And of course, we're going to have some time toward the end for questions. But if you have any questions while this presentation is going, please feel free to put your questions in the chat, and someone will definitely get to your question and answer it. So with no further ado, I'm going to get started here, talk about why customers move to VMware or move VMware workloads in Azure at the very beginning, right? So you have your organization today, you have existing VMware on-premises environment, you have your VMware skill sets and operations, and then you have probably a VMware license or even subscription now with a VCF. And then you probably, as a customer, thinking about some of the concerns or considerations you're looking at today. One of them is, the changes in the pricing model or how Broadcom actually sells VMware vSphere today through VCF, and that's concerning for some of the customers. And then some customers are also kind of tired from data center expiration, lease expiration, and software end of life, and they have to kind of keep owning that and maintaining that. Some customers express, concerns about the urgency and capacity, and we have, that chipset shortage, which is still kind of affecting us even these days, where customers not able to easily scale up their environment at on-prem. And of course, security threats is kind of factor. Even ransomware attacks at on-premises is very kind of trending, and we always try to help customers find ways to avoid having those scenarios. And then, of course, customers are also always tired from software and hardware refreshes, which kind of comes every, 3 or a couple years, and the customers have to start planning for the next refresh immediately after they're done doing the first refresh. So that's an ongoing problem where customers kind of are exhausted from that. And then, of course, budgets and resources constraints. I mean, you have to think about your infrastructure, manage, basically an environment, all the things that comes when you're like working in the CapEx world. And we're trying to kind of help the customer to move from the CapEx to an OpEx kind of model. And of course, scalability, right? As we talked about, capacity needs, and customers also want to have an easier way to scale up their application and modernize with Azure services, with the latest kind of data and AI services that we have today in Azure. So Azure has a lot of benefits that could cover all of these concerns that the customers might be thinking of, including price protections, giving agility for the business and IT, elasticity in scaling, increasing security and resiliency. And of course, when you move to with AVS, for example, you get proximity to the data and AI services that we have in Azure. And of course, Microsoft is always first when it comes to developer innovation. So whenever you use Microsoft tools, you'll be able to excel as a developer or kind of any innovation you're working on. And last but not least is, if the customer today have any, objectives on meeting any sustainability goals and with carbon reduction, that's also achievable whenever the customer moves into Azure or migrate the workloads into Azure VMware Solution in specific. I always describe Azure VMware Solution as the least risky and most rapid migration to the cloud or to Azure in specific. It basically begins with you moving your VMware workloads. I could say lift and shift, but I like to call it reallocate because it's another VMware environment. And you relocate your workloads from on-premises to the Azure VMware Solution private cloud running inside of Azure. And Microsoft also gives you mechanisms to lock in prices and get discounts with reserved instances. And we'll talk more about that. But today we have 1 year, 3 year, 5 year reserved instances that kind of remediates any concerns that the customers would have about price changes, at least in the next 5 years, because that's kind of the maximum period of time that we offer reserved instances. And when you also think about that, you're not only locking the pricing, you're also getting discounts. So for the 3 and the 5 year reserved instances, you can get up to 50% discount on the AVS pricing. And then once you're Azure, basically with Azure VMware Solution, you are at your own pace as a customer to think about modernizing your workloads. We have more than 200 services in Azure that you can take advantage of to start modernizing your applications, even while they're running on the VMware environment in Azure. So you can attach to Azure storage, Azure databases, and it also expand with even the latest AI services that we have today. So that's modernization, but that's on your terms. There's no rush. You can always stay on AVS, but if you just start thinking about, bringing AVS with other Azure services, it's definitely feasible and possible, and that's also recommended. With that, you would be able to achieve better business results, and that will help, customers, which I think I've been hearing from all the customers, they always have technical depth, and who doesn't? And with a migration like this helps the customer to free up resources and focus more on the innovation, and of course, retire the technical depth. All right, so what is Azure VMware Solution? If you look at this slide, you see kind of the left side and the right side looking very similar because that's what AVS provides, kind of the symmetry for for a VMware environment that comes in a managed format as a first-party service running in Azure. So you would see the same ESXi host, the same probably networking or similar networking and storage offered, and that's what you see on the right side of the screen. The left side of the screen, this is more what you have on premises today. And then through connectivity like express routes from on-premises into Azure VMware Solution, or even VPN, if you don't have express route, you'll be able to start migrating your workloads or your VMs from your on-premises environment using tools like VMware HCX and do kind of a vMotion migration, moving those VMs to the Azure VMware Solution environment. And if also think about AVS a little bit, I want to expand a little bit more about that. It's basically running on a bare metal hardware as a hyper-converged infrastructure. So you technically, like if you go to the Azure data center in a certain region, you'll find like blades running ESXi host natively. Like there's no nested virtualization. It's kind of basically on the bare metal hardware. And we have kind of a minimum of 3 nodes in any private cloud deployments. But then from there, you can expand into multiple nodes in the same cluster up to 16, or you can have up to 12 clusters in the same private cloud. If you need more, you can always provision additional private clouds and connect them together. And that's how you can scale AVS easily. It's kind of a VMware as a service. So you can always add additional nodes as you need. You can always scale up, scale down, as you need and as your workloads require, basically on demand. So there's no need to kind of reserve, nodes that you don't use and pay for it while there's no consumption on those nodes. Last thing I would say on this slide that this solution is always verified by Broadcom/VMware. So we always run the stack that VMware is also supporting as well. So if you're worried about that part, it's part of what we're running through building the service. And then moving to next slide here, you can see that once you're in Azure VMware Solution, you're kind of having that proximity with Azure services and Azure APIs. So you can always manage your VMware environment as a first-party service, or even as a first-class citizen service in Azure. If you even Arc enable your VMs, you can actually manage them and and have them as visible in the Azure API and Azure portals. You can manage them from there, and also can integrate them with services to help manage them through the Azure services from a security standpoint, monitoring, expanding on storage, connecting them with Entra ID, etc. So all that is possible. And also, if you want to modernize with Azure AI and data services, that is also possible while you have there. And as I mentioned, AVS runs in the same house as we run Azure services, so latency is neglected out of the equation, and the performance is the highest that you ever would possibly get when communicating between native Azure services in the same house. And then, of course, you beyond modernizing on expanding with Azure services, you also have what we have at our Azure Marketplace from our partners and vendors. So we have solutions like Pure Storage, Jetstream for DR, and Zerto for DR. All these available today to expand with your Azure VMware solution as well.
Awesome. There are a couple of questions from attendees regarding these. I would like to read it out for you.
Please.
So the first question is, I have already renewed my licenses with Broadcom and moved to VCF subscription. If I want to migrate to Azure VMware Solution, can I still benefit from my VCF investments?
Yes, that's actually a great question, which kind of trending these days. So last couple months, actually in September, we announced general availability for VCF subscription mobility to AVS. So that means if the customer already invested in VCF subscription from Broadcom, they can still migrate, or let's say migrate their workloads and reuse their VCF subscription. That kind of comes with additional pricing discounts on AVS. So AVS usually comes with the software licenses, the hardware, and the support. So if the customer bring the licenses or the subscription with them, then they only pay for the hardware cost and also the support that Microsoft provides. So that is definitely feasible, and the customer don't necessarily would lose their investment in their VCF subscription if they want to move into AVS.
Another one, how do I pay for Azure VMware Solution? Is it per VM or per physical host?
That's a good question too. Yeah, so you pay technically per host, not per VM. And we have multiple SKUs. Today we have AV36P, we have AV64, which is our latest and greatest that runs on Azure Fleet hardware. And you start your deployment with 3 nodes. So you have to pay 3 nodes at the very beginning. But then if you want to scale up and add more nodes in the cluster or have additional clusters, you'll definitely pay per node. And we have our pricing available and how much the node cost. If you go to aka.ms/AVS pricing, you will see the details. And of course, as I mentioned in the previous slides, the pricing also we have offers like reserved instances, which gives you discounts on the cost of the node, up to 50% if you go with a 3 years or 5 year reserved instances.
Thank you.
Perfect. Thank you, Ravi. Great questions. I want to kind of move on, and probably this is kind of my last or at least one slide more after this. So as I mentioned, basically AVS comes with a hyperconverged infrastructure hardware, and with the deployment, you get storage through vSAN. So vSAN is part of the service. You already get storage with the service itself. But what if you have more storage intensive workloads and you only need storage and not additional compute requirements? As Ravi, to your question before, you were saying, how do I pay? And you definitely pay per node. And if you only pay for additional node just for storage, probably that's not the most cost efficient way, because you're underutilizing your compute and memory as well. You definitely want to pay for the node when you're consuming everything, the CPUs, the memory, and the storage. So if you're only thinking about expanding storage, we have ability with AVS to attach additional data storage services we have today in Azure as a data stores on the private cloud. So we have 3 options today. One is the Azure NetApp Files, which attach as an NFS data store to AVS and provides multiple SKUs for performance. And then we have Azure Elastic-SAN, which we announced last month as a generally available solution. Also, it's a VMFS, attaches to AVS through iSCSI. And then we also have, through our partners, the Pure Storage Cloud service. It's also another VMFS data store that can be attached to AVS through iSCSI. And all these 3 services help the customer, in this case, expand storage efficiently, independent from scaling on compute and memory. And it eventually helps to reduce the total cost of ownership and operation as well, because you'll be kind of paying with what you need, and there's no over provisioning from a storage perspective. You just pay for what you need from the resources. And with that, I'm going to move to the last section, at least that I'm presenting today, which is basically what you get with Azure VMware Solution. And I'm trying to kind of, not to drain this slide, there's a lot on this slide, but I'm trying to basically summarize it in a few pillars here. One is the Microsoft benefits. So definitely you can transact AVS through Microsoft. And if you have any Mac commitments, you can also decrease your Mac commitments with Microsoft. You get lock pricing and discounts with 1 year, 3 years, and 5 years reserved instances up to 50%, and that's what you offer today to the customers. And then if you have with Azure, we have Azure Hybrid Cloud, our Azure Hybrid Benefits, and if you have software assurance today for Windows and SQL, you can definitely bring your own SQL and Windows licenses to AVS. You don't have to repurchase it. And then what's very special on Azure VMware Solution, very exclusive, that you get free extended security updates. Again, free extended security updates, ESUs, if you move your legacy Windows and SQL servers into Azure, that if you don't move them and you keep them on-prem, you still have to pay extended security updates costs for those workloads. And I'm talking about Windows Server 2012 and SQL 2012 and 14. And then again, as I mentioned before, AVS is the fastest migration option. So you move VMware workloads as is. There's no refactoring, no changes to your applications. Everything stays persistent and consistent with your operation as you have them today. And we have awesome partners like SNP that can help you actually doing all the migration. And that's kind of the meat of our topic today. And we kind of talked about that already. We have today the option to allow the customer to do VCF subscription portability and move it to AVS so they don't lose their investment on VCF subscriptions. And again, AVS is the service running on AVS, it provides familiar VMware tech stack. So the customer, when you use the service, they don't have to kind of ramp up with a new skill set immediately from day one. They can start with their VMware skill set and then organically learn Azure as they go. And AVS includes components that like vSphere, vSAN for storage, NSX for networking, and HCX for migration. So you continue to leverage your existing VMware expertise and skill set with the tools that you're already familiar with. And we talked about how you can expand storage independently from compute. And also we have, AVS as a first-party services. If you purchase it from Microsoft, everything support, licensing, billing goes through Microsoft. And it also allows you to manage the Azure or the workloads on AVS through the Azure portal and APIs. Also, if you Arc enable your AVS or Arc enable your VMs running on AVS, you can directly manage those services from the Azure portal and integrate them with other Azure services that help you manage your workloads and help you with your operations. And as I mentioned, AVS allow the customer to use VMware as a service to add capacity in minutes if you want to add additional node. Also, if you want to turn down a few nodes that you don't actually are using or utilizing, so you can save costs with that too. So it's a scalable, scaling up, scaling down, both options available. And then from a security standpoint, of course, we have plethora of security services that we have today on Azure that the customer can take advantage of. But we also offer things like disk encryption or vSAN encryption on AVS if that is required for some regulated industry that the customer might be running at. And as I mentioned, you can always scale with the security and management capabilities that Azure provides through the integration with Azure Arc. So last but not least, take advantage of the proximity with AVS to other Azure native services and Azure AI services. And as we mentioned, we have the special 5-year reserved instances option today that the customer can take advantage of. And then we also have a special 1-year offer for the 1-year reserved instance, which is 20% off the 1-year reserved instance. So that's a special, that's on top of the existing discount that the customer get. So the customer get typically around 29% with 1 year. And if they combine that with 20% off the discounted price, that will be around 43% in total. I'll put in the maybe the questions section, the link for the pricing. So if you have any questions, you can actually look at the pricing page and get the latest information that you need to know about AVS. And with that, I'm going to be mindful of the time. I'm going to switch over and hand it over to Ravi to talk about the best practices when you think about migrating to Azure VMware Solution and moving and using tools like VMware HCX. So I'm going to I think Ravi, you had the screen. So thank you. And you're now within Ravi's. Go ahead.
Thank you, Hosam. Thanks for the insights into the VMware solution and what it is offering to the customers. And we would like to discuss more on the actual part of the migration, what it is going to facilitate your migration to the Azure VMware solution. So as you consolidate the data centers and you are thinking to expand your data center presence into the cloud or completely replace the on-premises infrastructure with the Azure VMware solution, usually you get the questions around how exactly you're gonna deal with the migration, because there will be certain challenges when you are thinking about the migration. It may be related to the infrastructure incompatibilities, or it may be related to the network complexity. So some of the challenges like, okay, your mission critical applications, they require heavy uptime, and you cannot go with any downtime. You cannot have a downtime to maintain the mission critical applications. And migrating the servers from multiple sites you may be having the primary and the secondary data centers, and you would like to migrate all of them to cloud, and how exactly you can make it happen, and the performance degradation, that is another challenge, because when you are changing the platform, how your applications or the servers are going to behave, that is another concern. And your network bandwidth. So you may be having a WAN connection through your ISP, and that may be having some limitations, and how exactly your network bandwidth and your network is going to help you, or it is going to help you with the migration by offering more in terms of migrating the data over those WAN connections. And the compatibility with respect to the platform. So whether your VMs are going to run properly on the other platform or not, that is the major concern. So that's where we have the Azure VMware solution, which is helping you. And that's where the VMware HCX comes into the picture. How exactly VMware HCX is going to help you in migrating your on-premises VMware infrastructure to Azure VMware solution. And whatever the concerns we just mentioned, so VMware HCX is the answer to all those questions. So this HCX platform is going to automate the creation of hybrid interconnect to enable the organizations to easily and securely migrate the workloads to cloud. And leveraging HCX and the application mobility and data center transformation to the cloud is going to be seamless. So that's where the HCX is being used for all the migrations across from the VMware environments to the cloud environment. And the key capabilities of HCX. So it is going to help you in the bulk migration. So when you would like to migrate the servers in bulk, so that is the major thing which HCX offer. And you can simply schedule the movement of hundreds of VMs in parallel. And it is also going to help you enabling the mobility across data centers and cloud, and move VMs within your data center from your local data center to the cloud or across the cloud regions or providers to optimize your resource utilization. And the zero downtime. So if you would like to keep a particular mission critical application up and running, and you would like to go with the near zero downtime, then HCX offers the near zero downtime using the migration methodologies it allows. And IP re-architecting. So that is the major concern everybody usually has when we migrate the servers over to AVS, how exactly you are going to deal with the IP addresses. And HCX is going to help you in maintaining the same IP as your source environment. And also the compression and deduplication of data when you are migrating the VMs to the cloud, in order to just make sure that you have enough bandwidth for your regular operations. HCX also offers compression and deduplication while transferring the data over to the cloud. And those are the key capabilities of HCX. And when we are talking about HCX migration with respect to what it supports, and all the vSphere versions like 6.5 plus, it supports all the vSphere versions, and it also offers you online and offline migration, and it offers you the near zero downtime, and it also help you with the parallel migrations. And the L2 extension capability, that is about the maintaining the same IP schema, and HCX migration can happen on express route and also on VPN. There are some things which we have to definitely consider if we would like to migrate the VMs over the VPN, because there are the limitations like the bandwidth especially. So a minimum of 250 Mbps bandwidth is required if you would like to migrate the servers over to AVS using the VPN, and the maximum latency should be less than 150 milliseconds, and the packet loss should be 0.1% or less than that. And when you are thinking about large scale migration and large data migrations, we always recommend Azure Express Route over the VPN. So these are the considerations and these things you need to look into if you would like to migrate over the VPN tunnel. And the components related to the HCX. So there are a few major components, and those components have each individual purpose. And especially considering the migration between the on-premises VMware and the Azure VMware solution, That's where these components are going to form a service mesh in order to help you with the migration. And those components are HCX connector or HCX manager, we call it. And usually this acts as the central control point for the managing HCX environments. And this is typically deployed in both on-premises and in the cloud. And based on the location where you deploy this one, you name it like, okay, you call it HCX connector manager if you are deploying it in the on-prem environment, and you call it as HCX cloud manager when it is deployed on the AVS side. And the major responsibility of HCX manager is it is orchestrates the deployment of the HCX appliances, like maintaining the service configurations, and it is going to handle the updates, and it is going to monitor the overall health of the entire HCX environment. That is the major purpose of HCX manager. And the HCX connector, which usually we call it as HCX connector when you deploy it in the on-prem environment, and it serves as the link between your on-prem data center and the AVS. And it is installed in the source data center as mentioned, and it is going to facilitate that connectivity and service initialization, because we initialize most of these functionalities from the on-prem environment during the migration. The HCX connector is going to facilitate all those aspects. And when it comes to the cloud, it is other way around. It is going to help you in maintaining the connectivity between the HCX connector in the cloud and HCX connector in the on-prem environment. And it is going to support both the migration and disaster recovery scenarios. Because if you are thinking about AVS to AVS disaster recovery scenarios, and both the ends you will be having the cloud manager, and it is going to act as the communication point of contact between these both AVS in the disaster recovery scenarios. And HCX interconnect, we call it as IX appliance. And the major functionality of HCX appliance is it facilitates the secure migration of these virtual machines between these two environments. And the capabilities of these HCX interconnect is it supports all the vMotion bulk migrations, and it is leveraging the replication technologies, and it is going to securely transfer data over VPN or express route channels. And the WAN optimization. So this is the one of the key components. Though you use express route, you have the bandwidth which can support large scale migrations. Still, if you would like to make sure your communication, because you may be already having some additional applications running in Azure in the native Azure side, and if you don't want to overload your communication channel, and if you like to make sure you better utilize the bandwidth of the channel, then you make use of the WAN optimization appliance. It is going to help you with the data duplication and compression. So it is going to help in terms of reducing the load on your WAN channels, and you can make sure that okay, you have the enough bandwidth available for your regular operations. And the next one is the HCX interconnect appliance. So we are going to discuss more on the interconnect appliance side. So as we were mentioning about the WAN optimization service, it is going to reduce the latency, because it is going to improve the overall transfer speed as well, just to make sure you have the replication going in the defined timeline, and you also ensuring the data is moved quickly and efficiently between these two environments. That's where WAN optimization service is going to be key in both the cases, whether you use express route or the VPN. And the another major question we always have when we are doing the migrations is about the retaining the IP address. By having the servers in the on-premise environment for so long, and we don't know exactly where the hard-coded IP addresses are being used. And that's always a concern, whether it is the Azure VMware Solution migration or migration to the native Azure VMs as well. So here the HCX is going to help you in retaining your existing IP after the migration using the network extension appliance. So this network extension appliance, like advantage we get when we are maintaining the same IP schema in terms of the applications. So the application owners, as usual, they prefer to keep the same IP because they don't want to make any changes to the connection strings. They don't want to make the DNS changes. And with no IP changes, they get the option to not change anything within the code, and you do not have to change any firewall policies or your load balancing side. Whereas when it comes to the networking and IT team, so we always prefer to improvise. So the IT team may think like, okay, if you move to a different IP schema, you get to choose a freshly and newly designed infrastructure for your AWS environment. But always, if the question like if you like to keep your same IP after the migration, then HCX network extension is going to help you in maintaining the same IP even after the migration. So how exactly this is going to do? So in terms of maintaining the layer 2 network connectivity across these different sites, when we say different sites, the on-prem VMware is the primary site and the AVS is your destination or the secondary site. And extending the layer 2 extension between these two sites, that is the responsibility of the HCX network extension. And as mentioned, it is going to allow you to retain the original IP and MAC address during the migration, and it is going to ensure minimal disruption to your network configurations and the dependencies. And it is particularly useful for applications requiring consistent network setting post migration. As mentioned, there may be hard-coded IP addresses. Those doesn't need to be changed. So that's where the network extension is going to be helpful. And you have to have some requirements consideration if you would like to extend your layer 2 network to AVS, especially in terms of the switching. So all these networks which you would like to extend to Azure, they have to be attached to the distributed virtual switch. So standard switch, you cannot extend, you cannot do the layer 2 extension. It has to be distributed virtual switch. And also the Cisco ACI with VMM integration is not supported with the layer 2 extension. And when you extend the layer 2 networks, the major management networks like HCX uplink network, vMotion network, management network, and replication networks, this cannot be extended. And whatever the virtual machines you have on these management networks, you cannot even, you can migrate, but you cannot maintain the same IP after the migration if you have any VMs running on the management networks. So layer 2 extension will not work if you are using standard switch, and it is not going to work for the management networks like HCX uplink management and vMotion and replication networks. So all these network appliances, especially the HCX WAN optimization, interconnect, network extension, HCX manager, they all work together in the HCX service mesh in order to facilitate a seamless migration to Azure. And when you extend your network to the Azure, that is Azure VMware Solution, and all the traffic is going to flow back to your on-prem environment in order to reach out to the rest of the VMs or in order to go out to the internet. So that's how the layer 2 extension works. So the gateway for the extended network on the AVS is still your on-prem gateway. So all the traffic is going to routed back to your on-prem in order to send it to the respective VMs or to the external world. And while having this, we usually get a question. So if we move multiple VMs to Azure, so how exactly this particular path is going to create a latency between the communication of those VMs? So that's where we have the mobility optimized networking feature. So what exactly it does, as you see on the screen, so we have the VMs on the on-prem side. So there are a couple of VMs attached to the web tier and a couple of VMs attached to the app tier. And as part of the migration, we are moving one VM from the web tier and another VM from the app tier to Azure. And once it is moved to Azure, how exactly the communication is going to work between them. So if the communication from the VM attached to the web tier in the on-prem environment to the VM attached to the web tier on the AVS, it is straightforward. Like it is going to hit the tier 1 gateway of the AVS, and it is going to send the traffic to the on-prem gateway. That's where it is going to be routed to the VM. But what if the communication is required between the VMs attached to the two different segments, and those are in the AVS? So without mobility optimized networking, as you extended the layer 2 network and the gateway for the extended network is on-prem, the VM is going to send the traffic again back to on-prem. From on-prem, again, it is going to be flown to the VM sitting in the AVS. That means we are adding additional layers in the communication, which is going to increase the latency as well. If we enable mobility optimization for the layer 2 extended networks, the tier 1 gateway in AVS is going to make sure the communication is sent back to the VM in the AVS directly from the tier 1 gateway instead of sending it to the on-prem. The only challenge here is if there is a requirement for the outbound connectivity, outbound traffic from the VM, if you have to browse internet or if you have to send out something to the internet, then obviously your tier 1 gateway in the AVS should be having a path to go to the tier 0 gateway and a network virtual appliance sitting in Azure, which can help you with the outbound connectivity. So if you do not have that in place, and if you enable the mobility optimized networking, so then all the outbound related functionalities are going to be failed. So that is one thing which you have to keep in mind if you are planning to use the mobility optimized networking for the layer 2 extended networks. And when it comes to the kind of migration options the HCX offer, so it usually have all these listed down, like cold migration it supports HCX vMotion, bulk migration, replicated assisted vMotion, and OS assisted migration. We are going to just discuss about all these things, but we are going to focus more on bulk migration and replicated assisted vMotion because those are the two things which we usually see heavily during these migrations. So when we are talking about the bulk migration, it is going to help you in migrating the servers in parallel, many servers in parallel. And the only thing here with respect to the bulk migration is you will be having some downtime when it compares to replicated assisted vMotion. The replication is going to happen in parallel and the migration is going to happen in parallel. But whenever the migration is being initiated, the source machines will be shut down. So you are not going to have the connectivity to the on-prem machines, and the time it takes to migrate that VM to AVS, whether it may be 1 hour or 2 hours, then you will be seeing that 2 hours downtime if you are choosing the bulk migration. But it helps you in migrating several VMs simultaneously. Two things you have to focus on: replication, migration. Replication is parallel and migration is also parallel, but there will be more downtime. Whereas when we are considering the replicated assisted vMotion, in both the cases, the full synchronization happens, then the delta synchronizations are regular, but the major difference is going to be the migration point of whatever the schedule you define for the migration. And whenever you are doing the migration, with respect to the bulk migration is parallel, replication is parallel, but with RAV, replication is parallel, but migration is not parallel. So it is going to be sequential. If you have 30 machines in a group, and if you define a 4 hours maintenance window for the migration, all those 30 VMs will be migrated in a sequential manner. And whereas bulk migration, they are all going to be migrated in the simultaneous fashion. So that is the major difference between these replicated assisted vMotions and the bulk migration. And the reason why we are discussing more about the bulk migration and replicated assisted vMotion is that is the on the ground level, those are the two methodologies we seen heavily when somebody migrating from on-prem environment to AVS. And yes, HCX does support cold migration and also vMotion. And the cold migration using the NFC protocol, and vMotion is about the migration for the powered on VMs. And when you would like to migrate the VMs in the cold migration for the powered off VMs, it uses the NFC protocol. So it supports cold migration, vMotion, replicated assisted vMotion, bulk migration. The heavily used are bulk migration and replicated assisted vMotion. And the major usage tips with respect to HCX. So whenever you would like to migrate database servers in high availability mode or in clusters, prefer to use the native methodologies in order to expand those clusters to AVS and migrate the VMs to AVS. And when it comes to the domain controllers also, we recommend you to add the additional domain controllers, then move the roles instead of just migrating the Active Directory server. And vCenter and NSX Manager, they should not be migrated. And live migration is not available when migrating from the newer host platforms to older platforms. And service mesh when moving HCX fleet appliances to a new cluster. And disable backup software, especially because the snapshots are going to give the trouble when the final sweep happens. And if you are using backup solution, which also depends on snapshots, we disable those backup softwares during the migration window. So these are some of the HCX usage tips. And I would like to hand over to my colleague Firoz to continue with the network considerations. Thank you.
Thanks, Ravi. So here, as part of the network architecture, we would be going ahead and discussing about 3 different architectures which are mostly common when we are going ahead and leveraging AVS and migrating to AVS. The first one is going ahead and using a secure virtual WAN hub with Azure Firewall for all the application connectivity and the outbound internet connectivity. The second being the Azure Firewall, which is the native solution of Microsoft within the hub virtual network. So when I talk about a hub virtual network, it's actually a VNet, which will be acting as a transit VNet for all the application connectivity. And the third architecture that we will be going ahead and looking at is the third party virtual firewall. So I'm sure there are a lot of third party solutions that are being leveraged from Palo Alto's or FortiGates. So we will look at the third option as well. So the first, what we are looking at is the virtual WAN hub. So here, what you're looking at is how we could go ahead and establish a connectivity between the on-prem and the AVS. So here, unlike going ahead and establishing an express route from the on-prem, here there would be an additional step first on the AVS side. Firstly, from the AVS side, we would like to go ahead and connect to the Azure Virtual Hub. So what you're looking at is enabling a express route circuit from AVS to the virtual WAN hub. So there will be an gateway and a gateway express route gateway that would be established, and which would let us enable connectivity between Azure and AVS. So do understand that having an on-prem connectivity to AVS directly is only through an express route via a virtual WAN hub or a transit gateway. So here, if we are going ahead and considering a traffic flow between the on-prem, so the on-prem connectivity would be through the express route using the express route global reach, going to the AVS express route circuit and reaching the VMs within the AVS. So that's how the traffic flow would be. And from the Azure, it would be directly through the express route gateway. So considering there are any resources on the spoke VNet, it would be transitioning through the virtual WAN hub over the express route to the AVS. Now, there might be questions around how would AVS resources, so the VMs within the AVS, reaching the internet. So here, yes, AVS would still rely on the express route circuit. So it would use the express route circuit to reach the virtual WAN hub and leverage Azure Firewall in this scenario to reach the internet. There are other solutions as well where maybe there is a site-to-site connectivity or a point-to-site connectivity that would still needs to transit over the virtual WAN hub. So this architecture is definitely something that has a little bit of limitations. From the limitation perspective, there is no inspection that can happen between the AVS to the on-prem. So you could go ahead and see that if AVS needs to reach to the on-prem, it would leverage the express route, use the express route global reach, and reach the AVS. So there is no way that we could enable inspection until if there is an on-prem firewall in this situation. But definitely an advantage where you are simplifying the routing over here. You are going ahead and having a centralized management of routing within the virtual WAN. But as I mentioned, there are definitely limitations. The further limitations as well includes having a public IP prefixes. We will go ahead and discuss more about the public IP prefixes in the next slide. But here, when we talk about public IP prefixes, it's a continuation IP range, a public IP range of a /27, which cannot be allocated over here for virtual WAN. So that's one of the reasons we have also another architecture which looks at all the limitations of what virtual WAN hub could not offer. So here, on the similar lines as the previous one, there is always an express route connectivity that's required between the AVS and the hub VNet. So here the hub VNet is similar to a virtual VNet on an Azure, which is acting as a transit. So why exactly transit? Because this VNet is where we will have all the express route gateways, all the VPN gateways, and the Azure firewall, along with a route server. So why exactly a route server? So the route server is where we would leverage to exchange the routes between the AVS and the on-prem as well. And it also makes it an high availability solution in terms of switching between express route and the VPN. So the VPN over here is considered as a backup where the express route is the primary. And similarly, on the internet connectivity standpoint, the AVS, if the AVS resources have to reach the on-prem, they will have to use the express route circuit, reach the hub VNet, go to the Azure firewall and to the internet. So here you could go ahead and consider that the Azure firewall would go ahead and do the inspection, the traffic inspection between the internet traffic and the AVS. But on the similar lines here, to go ahead and inspect traffic between the AVS and the on-prem, we have to rely on the on-prem firewall because there is no firewall as a inspection that is happening between the AVS and the on-prem. So if you would consider that there is inspection that is required for every communication that's happening between the on-prem, then we will have to rely on the next architecture, which is the leveraging the third-party firewall. So here, when I mention as a third-party firewall, these are solutions or firewall solutions outside of Microsoft. Here, NVA, a network virtual appliance, can be anything around a Palo Alto or a Cisco or a FortiGate as well. Those are they are a long list of supported devices which can be deployed as a standalone device on the virtual hub. So here, there won't be any limitations as such. Here we can, the traffic will still remains the same from the AVS standpoint. Anything on the AVS, the VMs, the applications, all those still have to transit to the hub VNet, and using the default route, which is on the NVA, which is the Azure the NVA, the Cisco's or the Palo Altos will then connect to the internet user or connect using the express route as well. Here, the advantage is the traffic that's being transited over the VPN or over the internet can be inspected. So anything that's going to the on-prem can go via the express route or the site-to-site VPN can be inspected and can be filtered as well as per our. And here we will not have any limitations from the IP prefix standpoint. So we could go ahead and have a sequential IP prefix, maybe a /27 of an IP public IP range that can be assigned and that can be configured on the NVA. On the previous slide, as you could go ahead and see on the Azure firewall, yes, IP prefixes are allowed, but there is no single IP natting that can be done for all the outgoing traffic. So Azure firewall will pick any of the IP from the IP prefix and route to the internet. Here we have an advantage. So we will have, there might be scenarios where a whitelisting of IPs are required. So that can be done where NVA can have a IP prefix and it can be it can NAT for all the outgoing traffic as such. One more advantage of having this architecture is the flexibility of bringing your own IP as well. So bring your own IP is taking the same range that is being used on-prem. So the range can be anything between anything that is being used for within your environment. Let's say you already own an IP range which is being advertised through your carrier, which can be leveraged and which can be bought to Microsoft as well. So as you have seen the three architectures, I would like to go ahead and present a decision chart on how or where these architectures can be chosen. So there is this decision charts will let you decide which path to go with. Would you want to go on the virtual WAN side, or would you want to go with the Azure firewall along with a hub VNet or a third-party firewall? So here it's a pretty easy start where if you already have a bring your own IP where you have a /24, so for a bring your own IP, by default, it's a /24, which is accepted. So you could go ahead and migrate your IP range, which you own on Azure. So if you already have a bring your own IP, then you need to ask, would you need a source NAT? So source NAT is basically having that one single NAT as an outgoing IP, where, as I mentioned, they might be a whitelisting requirement, or you might have only one single IP that needs to be used for outgoing traffic. So if there is a source NAT that's required, then third-party firewall along with the hub virtual network is the path. Let's say if you don't have a bring your own IP, but still you would require a prefix like a /27 of a public IP range. Still, you need to go ask yourself, is this NAT, the source NAT, is required? If you don't have a source NAT, but still you would want a prefix, you can use Azure Firewall along with the Azure VNet, as it would not have any restrictions or where the IP range or the IP prefix can be assigned on the Azure Firewall, you can still maintain it. But if you don't have a prefix, if you don't have and bring your own IP requirement, you can still proceed. And if you don't have a SNAT, you can proceed with a virtual WAN. As if you already have a virtual WAN, or if you are looking forward to see a SD-WAN solution, the Azure deployment with the AVS deployment with secure virtual WAN is the solution to go with. So there might be questions around what exactly is the process with bring your own IP, or how do we go ahead and get started over there. So it's a pretty easy process. Microsoft has made it really easier for you to go ahead and bring that IP range or the IP prefix that you own onto the Microsoft side and let Microsoft advertise it. So it's about going ahead and getting started with validation, where Microsoft would validate if you really own that IP range and will let you advertise that as well. So as we move forward, I would like to go ahead and hand over it to Ravi, where he would like to go ahead and discuss about the DR scenarios.
Thank you, Firoz. Okay, so we are sorry guys, we are running a bit behind, and please forgive us. We would like to continue this, and we would like to be quick. So as per the agenda, we wanted to discuss about the disaster recovery options which AVS offers, right? And there are multiple options you have, but we are going to focus only on the site recovery manager for this session. And Site Recovery Manager, Z2, ZStream, they all offer disaster recovery from AVS to AVS. Whereas Azure Site Recovery, if you would like to use Azure native solution for the disaster recovery, you can use the Azure Site Recovery for the disaster recovery. Here, we would like to focus more on the SRM. And when you are talking about the solution with respect to the disaster recovery using SRM, the both AVS solutions are going to be connected using the ExpressRoute global reach, and you will be having the ExpressRoute gateway anyway on both the AVS sites, and you will be using the same ExpressRoute gateway in order to establish the global reach between those two Azure VMware solutions. And that's where the both AVS solutions will start communicate, and whatever the spokes and whatever the hub networks you have in both the regions, the resources in those hub networks and spoke networks also be able to communicate with the hub and spoke networks in the disaster recovery region through that global reach. So you are enabling the communication using global reach, just not between the Azure VMware solutions. You are also enabling that communication between the hub and spoke networks sitting in the two different regions. And when we are using SRM, Site Recovery Manager, for the disaster recovery, so two things that comes into the mind, like, okay, what exactly happened? I used the same IP schema while migrating the servers to AVS. Now for the disaster recovery also, I would like to make use of the same IP schema. I don't want to change. Does Site Recovery Manager offers? Yes, Site Recovery Manager, it offers you to maintain the same IP schema even while setting up the disaster recovery in Azure between the Azure VMware solutions. The only thing, the major point which we have to remember is, as both the AVS are connected using the global reach, the segments you create in the destination side, that is the DR region Azure VMware solution, those segments you cannot connect them to the tier 1 gateway, because once you connect to the tier 1 gateway, the ExpressRoute gateway is going to publish that network information to the route server in the hub virtual network, and there will be a conflict of the routes between the source VMware solution, that is the AVS on the primary side and AVS on the disaster recovery side. So what we recommend and what we have to do, if you would like to maintain the same IP schema, you have to disable the tier 1 segment. You have to disconnect the tier 1 gateway for all the segments during the disaster recovery replication. At that moment, whenever you would like to fail over the servers infrastructure over to the secondary region, that's when you connect the tier 1 gateways on the secondary side. Until that period, you are not going to connect the tier 1 gateway. That is the major point. And second thing, when you are maintaining the same IP schema, you are limited with the partial disaster recovery, as you are not connecting the tier 1 gateway to the segments. And if you have to connect, you have to completely connect to the entire segment. That means your partial failover can happen only at the segment level, not at the application level. If you have an application where database servers are in a different segment and app servers in a different segment, then you have to switch both the segments. So your disaster recovery option is limited here, as you would like to do the partial DR It is only at the segment level, not at the application level. So that is the major thing. And when disaster happens, so as mentioned on the screen, when you have the same IP schema and replication is going on, all the IO traffic and IPsec tunnels are going to the primary region. And whenever you have the disaster recovery, when you have a problem in the production region, or if you are doing the partial disaster recovery, the IO traffic related to those applications and the VPN tunnels related to those segments, those are going to be active to the secondary side. And the tier 1 gateway is active on the secondary side, and tier 1 gateway is disabled on the source side. So that is the major difference when you are maintaining the same IP schema. And when you are looking for the different IP schema, so you do not have all those challenges. You can have both the tier 1 gateways connected to the segments, because anyway, there are two different IP schema. Publishing those IP ranges to the network is not going to be a problem for you. So then it is absolutely fine. And your even the failovers, partial failovers can happen at the application level as well. You don't need to be at the segment level. It can be done at the application level as well. That is the difference between the same IP schema and different IP schema. And this is the quick glance on SNP's AVS approach. So we always recommend to have the landing zone set up before you initiate any migrations. And the network implementation is going to play a key role that has to be there before you migrate the servers. The migration discovery planning, then the migration setup and pilot, then the production migration, and protecting the backup workloads using backup and DR, and setting up the monitoring for the AVS environment. This is SNP approaches to the AVS migration. And if you have any questions, feel free to ask. I think we answered the majority of the questions in the Q&A section. And if anybody has more questions, feel free to reach out to sales@snp.com and we will contact you. Thank you.
Awesome. Thank you so much, Ravi and Feroz, for this all insightful presentation. It was a lot of information helpful to our customers to understand more how they can implement and adopt Azure VMware Solution.
Thank you, Hassan.
Thank you, Hassan.
Of course. All right. You think we still have time for questions, or are we good?
I don't see any new questions in the chat.
There was a quick question maybe we can handle before we wrap it up. There was a question saying, can we use HCX as a DR solution? I know we have talked about like Zerto, Jetstream, SRM. Can we use HCX for DR?
Yeah, we can definitely use HCX as a DR solution, but there are some limitations with respect to the failovers and failbacks. So that's the reason we mentioned about the solutions that is native and also third-party solutions, but not the HCX. Yes, HCX is definitely can help with the disaster recovery, but the recommendation is not to use in the production environments.
Yeah, that makes sense, because it doesn't also provide that orchestration that typical DR solution also provides. That's yes, like the other DR solutions provide like a full like end-to-end orchestration for like failover and failing back. With HCX, like you have to manage a few things like manually, but that's one of the limitations like I'm aware of. So yeah, definitely to your point, Ravi, it's not recommended for production, but it can be used. Good. I know we're over the time, so I'm be respectful to everyone on the call. But thank you so much again, SNP team. Great work here on the presentation. And I guess the contact is sales@snp.com, correct, Ravi?
Yes.
Yeah, maybe we can put in the chat. But yeah, so if you need to kind of excel with your AVS implementation, reach out to the SNP team. You're with the best hands to get you your AVS migration done, or any Azure migration projects done smoothly as well. Thank you so much and have a great day.
Thank you all.
Thanks, everyone. Thanks for joining.